Hello and welcome. Today we're going to discuss about the introduction to vectors, as well as what's the meaning of magnitude and direction. So what are vectors? First, you have to know that there is a physical quantity, and that physical quantity is divided into two, which is a vector and a scalar quantity. So the difference between vector and scalar quantity is that vectors require, or they are represented, magnitude and direction, but scalars, they are represented with only magnitude. For example, as you can see here, the length or size of the vector, for example 5 meters 20 newtons. Now this is just a scalar quantity, but when you add a direction to it, like 5 meters north or 5 meters east, it becomes a vector quantity. How are vectors represented? So there are two types of ways to represent a vector, that is a notation and a graphical representation. So notation is representing a vector using bold words or just adding an arrow above the letter. For example, for a force, you either write an F that is bold like this, or an F with an arrow above. And the second way is the graphical representation. So a vector is depicted as an arrow. The length of the arrow corresponds to its magnitude, and the direction in which the arrow points indicates the vector's direction. So this means if I have an arrow that points to the north, let's say upwards, and let's say the magnitude of that arrow is 5 meters. So that now it's a vector because it's 5 meters long and it's pointing towards the north. That's what graphical representation means. So there are different types of vector quantities. The first one is displacement. So what's a displacement? It's the shortest path to a destination. Instead of, the distance is, the whole. For example, let's say I want to go from city A to city B. There are left and right turns. You cannot directly go, right? So if you include the left and the right turns, maybe it's 100 kilometers. But if you go directly, which is the displacement, it's gonna be shorter. It's gonna be 50 kilometers. So here as an example, it's given a car travels 50 miles east from city A to city B. So 50 miles is the magnitude and east is the direction. So this is the example trying to tell you. It's going to give you an example and it's going to tell you to pick out which one is the magnitude and which one is the direction. And the second example is force. So a force is a push or a pull. And the example is pushing a box with 200 newtons of force to the east direction. So 200 newtons in the example here, 200 newtons represent the magnitude, and east here represent the direction. Okay, now the third example, velocity. So velocity, it's a rate of change of speed. And as an example given here, 25 miles per hour. So 25 miles per hour is the magnitude and southwest is the direction. So now let's go to the questions. So the first question is the temperature a vector or a scalar quantity? And the second question, if a boat travels at 50 miles per hour due north and the current flows at 3 miles per hour due east, how would you visually represent the boat's resultant velocity vector? Okay, the answers in 3, 2, 1. So the temperature is a scalar quantity, as also there was a hint for the first question that says, does it have a direction? This is really important because to determine whether a quantity is scalar or a vector quantity, you have to ask yourself, does it have a direction? If yes, then it's a vector quantity. If no, then it's a scalar. In case of this question here, temperature is a scalar quantity because it doesn't require a direction. You just tell 25 degrees Celsius, that's it. All you need is magnitude. Direction is not required here. And the second question, the boat's resultant velocity. So you don't need any calculations here. It only told you to represent it visually. So you can represent as the picture shown here. It goes north and then to the east. So to represent the boat's resultant velocity, draw an arrow pointing to the north, because first it said if the boat travels at 15 miles per hour due north. That means first the boat traveled to the north 15 miles per hour. And then from its tip, that means from the tip of the boat, draw a second and a shorter arrow pointing east to the current. Yes, because it says shorter because the way you go to the north is 15 miles per hour while the current is only 3 miles per hour. So the second line should be shorter. So we go 3 miles per hour to the east. Even though this one's pointing to the west, just you have to understand the concept. So the resultant factor is the diagonal arrow connecting the starting point to the tip of the second arrow. This means starting from the bottom or the beginning of the north arrow until the ending of the second arrow that is pointing to the left. You see that one without the turn. That means the displacement. Simply the displacement. That's the resultant vector. That means from the bottom, from the beginning of the north arrow and until directly to the end of the second arrow. In conclusion, vectors offer a precise language for phenomena involving magnitude and direction. Thanks for watching, and I'll see you in the next video.